Hi, good day everyone. So I'm Joyce, and as part of our requirements for the scores, trends and issues and psychological research and practice under Dr. Romel Serio, I'll be sharing my report entitled Rewiring the Mind, Integrating Neuroplasticity into Modern Mental Health Treatments. Okay, so over the next 20 minutes or so, we'll be exploring what neuroplasticity is, how it works, how it's applied in mental health treatments, the ethical challenges that come with it, and finally, how we can use this knowledge or in our everyday practice as mental health professionals or advocates. Okay, now I want you to look at this slide. It is showing a stroke patient who learned to walk again. And on the right-hand side, it's an older adult who has learned to love the aging process and who has overcome her fear of riding airplanes. What do you think they have in common? Yeah, you guessed it right. It's neuroplasticity. Now, we often hear the phrases, it's all in the mind, quote unquote, mind over matter, or change your mindset. But what if I told you that science has shown we can actually change the structure and function of our brains? That's a promise of neuroplasticity, the brain's incredible ability to rewire itself throughout life. So the term neuroplasticity comes from neuro, meaning neurons, which are the building blocks of our nervous system, and plasticity, which means flexibility or malleability, or the ability to change. So simply put, neuroplasticity is the brain's lifelong ability to change, reorganize, and form new neural connections in response to experience, learning, or injury. It's also the ability of the nervous system to change its activity in response to intrinsic or extrinsic stimuli by reorganizing its structure, functions, or connections. And some of these popular definitions come from Mateos Aparicio, Rodriguez Moreno, Merzenich, Kandel, and Deutsch. And traditionally, scientists believe that the adult brain was fixed, that after childhood it stopped growing or changing. But research over the past few decades have proven otherwise, that our brains remain dynamic throughout life. So the brain is dynamic and it's not fixed. And there are two main types of plasticity. So you have structural plasticity, which is when the brain physically changes its structure through learning. And the other one is the functional plasticity, which is the brain's ability to move functions from a damaged area of the brain to other undamaged areas. And this is why stroke survivors can sometimes regain lost abilities and why practicing new habits or skills can literally reshape our brains. The core of neuroplasticity are mechanisms such as long-term potentiation or the strengthening of connections between neurons that fire together. As the Canadian psychologist Donald had famously said, neurons that fire together wire together. And there's also another process called synaptic pruning, which refers to the removal of unused connections, allowing the brain to become more efficient, like tidying up a cluttered workspace. And there's this saying that goes, use it or lose it. So it's just like that. You know, when you have things that you don't normally use, you tend to forget them, right? Or you tend to forget about them, that you even have it. So that's what happens to the brain. So similar to that is what happens to the brain. There's also this concept called neurogenesis, or the creation of new neurons, occurring even in adults, particularly in the hippocampus, the region of the brain that is responsible for memory and learning. Okay, and the next slide, I can share with you a short clip for better visualization of these scientific concepts relative to neuroplasticity. Speaking of science, you might wonder, what some evidence-based research are backing up neuroplasticity claims. So there are several landmark studies that demonstrate how neuroplasticity works in real life. Okay, speaking of science, you might ask or wonder about some evidence-based research to back up neuroplasticity claims. There are several landmark studies demonstrating how neuroplasticity works in real life. And one of the most compelling demonstrations of neuroplasticity comes from Maguire et al. In 2000, who studied the brains of London taxi drivers. So these drivers who undergo extensive training to memorize the intricate layout of London streets, a process known as the knowledge. These drivers showed significantly enlarged posterior hippocampi compared to non-taxi drivers. So this hippocampus, like I mentioned earlier, is the brain region crucial for memory as well as for spatial navigation. And the study revealed a positive correlation between years of driving experience and hippocampal volume, which suggests that repeated and prolonged spatial navigation experiences can physically reshape the brain structures. This finding provided strong evidence that environmental demands and continuous learning can induce structural brain changes even in adulthood. Similarly, Lazar et al. In 2005 provided neuroscientific evidence that mindfulness meditation can bring about measurable anatomical changes in the brain. So using magnetic resonance imaging or MRI, they found that long-term meditators had increased cortical thickness in brain regions associated with attention, interoception, and sensory processing, particularly in the prefrontal cortex and right anterior insula. Furthermore, subsequent research has shown that mindfulness can reduce amygdala activation, the region that's responsible for fear and stress responses, suggesting improved emotional regulation. And this demonstrates that sustained mental training can lead not only to functional but also to structural changes in the brain areas responsible for both self-awareness and emotion regulation. Lastly, Schwartz et al. In 1996 provided support for neuroplasticity through clinical intervention. So in their study, they had patients with obsessive compulsive disorders or OCD, and they demonstrated that CBT or cognitive behavioral therapy led to observable changes in brain activity. So using another medical device or equipment, positron emission tomography or PET scans, they found that after CBT, the hyperactivity in the part of the brain caudate nucleus and the prefrontal cortex normalized, so which corresponds with reduction in obsessive and compulsive symptoms. This finding was groundbreaking because it showed that the therapy or the psychological intervention through CBT can actually alter the neural circuits implicated in psychiatric disorders, emphasizing the mind's capacity to reshape the brain. So all of these studies illustrate neuroplasticity across different contexts. So that's in the context of learning, meditation, and therapy. So demonstrating the brain's remarkable ability to reorganize itself in response to experience, mental practice, and the intentional intervention. Now that we've seen how experiences can reshape the brain, it's also important to understand where many of these changes happen, particularly within the limbic system or the brain's emotional core. So the limbic system plays a central role in our emotions, motivation, memory, and stress response, all of which are key to how neuroplasticity unfolds. So I won't explain each and every part here, but just wanted to highlight the particular one. So the hippocampus, which we mentioned earlier, is vital for learning and forming new memories, right? And it's also this part that grows larger, or in the case of the London taxi drivers that I mentioned earlier, this part grew larger, showing how continuous learning can physically alter the brain. And then there's also the amygdala part, which is the brain's emotional alarm center. It processes fear, threat, and in the study by Lazar et al., So mindfulness was found to reduce its activity, meaning people can literally calm their emotional reactivity through practice. And then you have the hypothalamus, which links the nervous system to the endocrine system, the one regulating stress hormones, hunger, and other bodily functions. Then you have the prefrontal cortex, which is located at the front part of the brain. And this region is often called the brain's executive center because it's responsible for higher order thinking, decision making, planning, impulse control, and emotional regulation. And when we practice mindfulness or undergo therapy, it's the prefrontal cortex that helps regain the control over the amygdala, allowing us to respond to stress more calmly and rationally instead of reacting impulsively. So these parts work in harmony and process or to process emotion and memory, and through neuroplasticity, they can adapt and change over time. So, how does neuroplasticity relate to mental health? So, some of the evidence based studies shown earlier were prelude to the application in mental health treatments. When people suffer from anxiety or depression, their brain networks can become rigidly wired toward negative thought patterns. So, through therapy and lifestyle change, we can help clients form new neural pathways for resilience and emotional regulation. So, same goes for PTSD and fear extinction, and addiction and habit rewiring. Now, let's look at some of the key therapeutic applications. So, for cognitive behavioral therapy, so this uses neuroplastic principles to restructure maladaptive thoughts or maladaptive thought networks, and also using fMRI. Um, this can show or demonstrate the normalization of the cortical limbic activity after CBT. Then you have somatic and trauma therapy. So, my personal favorite, as many of you may be aware of. So, this pertains to the repeated experiences of safety in the body, which can rewire trauma responses. And clear with this type of or with this application, with this approach, clients can learn to associate calm states with safety and not threat. Next is mindfulness meditation. So we've talked about this earlier. You know, is very helpful. Building your new neural pathways can be used for for improving attention, compassion, and emotional regulation. And there are research showing that there's an increase in the gray matter and reduction in amygdala reactivity. Last but not the least, the emerging frontier. So these are some of the new initiatives around neuroplasticity. So neurofeedback, brain stimulation, and even psychedelic assisted therapies like psilocybin and ketamine are being studied for their plasticity enhancing effects. You also have the digital therapeutics, which are now being used um, and used alongside neuroplasticity based exercises to retrain mental habits through the apps and virtual tools. While the idea of rewiring the brain is exciting, it's also important to stay grounded in evidence. So, first, there's danger of overpromising, sometimes called the neurohype. Plasticity has limits and varies from person to person. We also must keep in mind that we can also face issues around accessibility and equity. So many advanced neuro-based treatments are still available only in high resource settings, leaving underserved communities behind. And then third would be ethical frontiers. So looking at informed consent, right? This becomes more crucial in neuromodulation or psychedelic treatments. And definitely data privacy. So this must be safeguarded when using neurotech and digital mental health tools. The good news is that, with all of this, neuroplasticity isn't limited to the labs or the therapy rooms, right? The good news for all of us is that we can apply it in everyday life. So for clients and or for clinicians and practitioners, this means integrating psychoeducation, so helping clients understand that healing is a process of brain rewiring, right? So combining therapy with lifestyle interventions for holistic mental health. And yeah, for clients and individuals, this means practicing mindfulness, journaling, learning new skills, maintaining healthy sleep, nutrition, and exercise. So, understanding that each positive habit literally reshapes the brain towards wellness. In conclusion, all these studies remind us that the brain is constantly changing. It's learning, healing, and adapting with every new experience. And as Dr. Michael Mrzenik, the father of neuroplasticity, said, to learn is to change how you think. So learning doesn't just add knowledge, it transforms the brain itself. And every mindful moment, every new skill, every act of reflection reshapes who we are, proving that growth and change are always possible. That being said, that concludes my report. I hope you learned something new today and share with you here my references for my report. Take care. Thank you again. Bye.